From 2019 to 2021, the Murney Tower Museum worked with a team of engineering undergraduate students from Queen's University on the creation of a portable, interactive display to show the public how our cistern works. What began as a 4-month school project turned into a long-term volunteer commitment from these enthusiastic students who made an invaluable contribution to their local museum. Here is the full story of Morgan, Naomi, Kate, and Julia, and their wonderful interactive cistern exhibit. What was the cistern and how did it work? The cistern would have been used to store rainwater for the soldiers to use for cooking and drinking when they were under attack. When the roof was removed, the gutter on the gun platform would collect rainwater so the soldiers would have a source of water in the tower. The rainwater would run from the roof through the piping system in the center column of the tower into the cistern, where up to 4,480 gallons of water could be stored. There is a pump on the main floor behind the front desk which would have allowed the soldiers to pump the water back up to be used. Back in 2019, the museum partnered with the Queen's University Engineering Department. As part of their ASPC 100 module, the first-year students were tasked with developing a prototype for a portable interactive display which would demonstrate how the cistern works. They were split into 2 teams and got started on designing interactive cistern prototypes for the museum. Here you see the first iteration prototype, which uses lights to demonstrate the movement of the water. In April 2019, 2 teams got together with the museum's former director, Graham Watson, to demonstrate the products of their 4-month-long work. Impressed with the quality of the work, the museum approached the students and asked if they would be willing to continue with the project by turning their prototype into a finished model that would eventually be displayed in the Murney Tower Museum. Interested in the opportunity of applying some of the things that they were learning about in university in a real-world engineering project, Naomi, Kate, Julia, and Morgan joined forces to further develop their initial prototype into a permanent interactive display. In the second phase of the project, the students decided to represent the water flow with LED lights and buttons, as it could withstand the conditions inside the tower, was mess-free, safe for kids to play with, and also engaging. For this, they visited a local school and made a presentation for one of the classes to assess how the kids liked the display and our presentation, as they understood that outreach to local children was an important feature of the display, all to make their display more engaging. Here you see the product of their work, the second iteration prototype, which utilizes electronics and lights to demonstrate how the cistern works. Now let's turn our attention to the students and listen to what they have to say.
Hi, I'm Morgan. I'm in 3rd year mechanical engineering, and our group started working on the Murney Tower project back in our 1st year of university. So it was a project with the university and the tower as part of one of our school courses. But once we were finished with our course, we were offered to continue working on it, which was super, super exciting. So I actually came from a different group. The 3 other girls, Julia, Naomi, and Kate, came from one group and I joined from another group. So it was quite interesting to join another team after 1st year and to try and tie all of our ideas together. I think it really helped though, because we had a lot of other people's ideas in the background that helped us really think about all the pros and cons of what we were doing and why we were doing it. And yeah, this project, it was just a really, really awesome privilege. I am really interested in project management, so it was really cool being able to see something like all the way through. We went through the entire engineering process with, report writing, design idea generation, to like creating an actual final product. And yeah, it was just really exciting to create an educational tool for the kids.
Hi, my name is Julia and I am in 3rd year biomechanical engineering at Queen's. I also had the privilege of working on this project and I saw it through from 1st year until now, and I'm really excited that it's finally getting implemented at the museum and also used for outreach purposes at schools. One of my favorite parts of working on this project was actually going to a school to go test it and seeing the positive feedback from all the children as they were interacting with our model and the joy on their faces while they were playing around with the different buttons and they especially really liked the little Lego pieces, so we got more of those. And yeah, so overall I am so grateful, and it's so fulfilling to see our school project being implemented in the community and being used for educational purposes, and I hope that everyone really enjoys it and learns a lot from it.
Hi, I'm Naomi. I'm a third-year engineering physics student at Queen's University, and since first year I've had the privilege to work on this Murney Tower project, and it's just been a really cool experience for me. I've been the one who did a lot of the electronics design and coding, so it was just a really great learning experience. I had very little experience with anything like that before I started this project, and I learned so much, and it was just really neat to be able to apply all these things that I learned to like a real world engineering problem that would benefit the community. It was also really great just to be able to work with such an amazing team and work with the tower, and it gave me lots of really good like real world engineering experience that will be super useful to apply in future jobs later on.
Hi, I'm Kate, and I'm a third-year biochemical engineering at Queen's, and I had the privilege of creating this display with the Murney Tower Museum. My favorite part was the design and building process, as it involved a lot of creativity, problem solving, and put into practice the engineering design process. We had to come up with the design and choose materials that would withstand the conditions in the tower, be safe, be portable, and be interactive for the kids. We had some limitations at the beginning of this project with budget, so we had to be really resourceful in the materials we got to use. But then with the support of Murney Tower and additional budget, we got to create the great display we have now. Thanks.
This wonderful team of enthusiastic and bright engineering students saw this project through to completion, all the way from idea generation to design and implementation. We would like to thank Morgan, Naomi, Kate, and Julia for their contribution and hard work. Their prototype will make a valuable addition to our exhibits for years to come.